Thanks, and welcome to this presentation of the Design and Data Milestone project within the Digital Twin City Center. I'm Jonas Rundberger, and I was lead of this project, which is finished but not fully completed, I should say. I was at that time at Chalmers, now I'm at White Architecture. So this milestone project regards the interaction between architectural design processes and urban digital twins. And it started with the hypothesis that in the early stage design and planning processes, important information is created, and of course, data is needed. And it also brings key value to urban development. There is also an emerging or quite established field referred to as computational design, which means that architects and designers develop bespoke and automated processes that deal with data. So for us, it seems very relevant that early stage design and planning processes can benefit from and contribute to urban data in different ways, also at the architectural scale. So the objectives here has been to identify data-intensive processes in these processes, develop automated design workflows within those processes that can use and deliver data to urban digital twins, and map these and propose a framework for how data can be exchanged. There are three main application areas that really depend on the partners that you can see to the right. Chalmers, of course, but also Liljeval, Foyab, Tengbom, and White as architectural practices, and Parametric as software developer. So these areas include bespoke generative design and processes at different scales, processes depending on architectural and structural design, interoperability and collaboration, and design to manufacturing processes. There were a number of case projects involved here coming from our partners, and that was a key asset that we considered to use live cases. Many of these were collected, some of them were not used so much. In the first case, one project was used only to test different cloud services. We had some organizational changes, and one of the cases moved actually to another milestone project. But I will talk now about 4 cases and go quite quickly through them to give an idea of what these processes can be like. The status, I should also say, is that these cases have been completed, but we're doing still the final conclusions on a framework that can enable this exchange of data. So the first case, Bällstahamn, is an urban renewal project in Stockholm where Tengbom was the architect. And it was used as a case for an automated generative design process and developed after the completion of the project. This is Bällstahamn, northwestern Stockholm, where Tengbom had developed a scheme. This is the particular area, and I will not go through the developed proposal, but rather go and look at the workflows that were explored and tested. In this case, the input used was GIS data from QGIS as a test. I will come back to Speckle as a platform that was used for data exchange. An urban generator was developed, and there's also tests for a building generator, and finally sort of a validation of the result. So this, on one hand, also depend on space syntax integration analysis and how the proposal affects that. But in essence, it was a quite direct exploration of the possibility to generate alternate street networks and see how that affected the surroundings. Also, to certain extents of volumetric generation. And one important notion was the assessment of parcels, the plots for buildings or other development. That was a key aspect that was analyzed in terms of its complexity or potential use. And the color code indicates that. There was, as mentioned, a very basic generation of urban volumes here as well, fully automated. And the cloud connector Speckle that I will talk a bit about later also enabled a visual aspect where the data being streamed could be at least reviewed. A final step was also tested a bit, which was more on the building generator scale, based on the input from the first process. This also relied quite a bit on development done by Liljeval. So these are some examples from their work that was brought in as a case. And the principle here is that these are bespoke generative processes developed by themselves for assessment. There are many other initiatives in this field, of course, now, but the second case relates more to the design structure interoperability, but also design processes. It was brought in by White Architecture, where I was also at the time, and still am, and a commission for 4 bridges developed in parallel in central Umeå. This led to a quite complex process with the 4 parallel design proposals being brought up, but also the complexity of the urban situation. So this set the need for a bespoke but quite robust workflow and a design system that could allow us to work with this. Briefly, the site, Norra Ön in Umeå, the new four new connections. And the design methods developed and used were also based on other bridge cases that we as a team had worked on. But that led to a quite good understanding of what's needed to explore the design, develop its geometry, and later on potentially also set it back into an urban context. The bridge principle itself follows quite a linear workflow with a number of different definitions. And I will just now quickly step through for a graphical presentation of this toolkit. That also includes analysis in different ways. There's the possibility to first automatically model a very simple geometry for rapid processes. In this case, identifying larger spans. Then the bridge deck as being produced, structure, and ultimately also the bridge superstructure, where different typologies could be used, and everything is parameterized and can be changed. So this is the final versions, also with trusses and a slightly more comprehensive view of the design system. So this process led to the possibility to develop these 4 different proposals and enable that. And of course, these images are real-time visualizations, so it also depended on getting urban data and geometry into the models to assess them in their context, something which was done directly from GIS data and information provided by the client, the municipality of Umeå. The next case is a series of methods and then emerging offer, we could say, that deals with reuse of materials used in early stage design at architecture scales. This was developed over a set of initiatives by White Architecture, and the whole thing is packaged into something that we call Remake. So 4 cases have been used, and in each project, the methodology has been developed further. The first case is, well, the principle, I should say, for us is really to connect the material library, a database of some kind, regardless of format, through an automated process with a design model, and allow direct interaction and iterative exploration, where you get updates continuously in real time on the material used and the climate impact, carbon footprint, etc. First started in a very small project for a pavilion where oak beams from an old sawmill in Järvsö were used, which eventually led to a pavilion that were at events and finally returned to Järvsö. But this is just to show a very immediate example of, imagine the design model to the right, which could be manipulated by the designer, and the direct feedback in terms of color coding if the beams exist in the stock seen to the left. Later on, it was developed further in a competition proposal in Berlin, Karlstadt and Hermannplatz, where there was a material library made available, and a design interface was developed for different aspects of reused materials, such as steel plates for ceilings in this case. And also in an ongoing commission for Lumi in Uppsala, where there was a complex situation of managing the reuse of hundreds of doors with many different criteria, such as fire regulation. So this allowed doors to be placed, and you could just use a matching algorithm to check for that it was each door is available. So these workflows were also documented and published actually to get more a better understanding of what's actually going on, which is a way to also it can be used to direct the roadmap for further development. So each reuse method is done as a small package, done completed, and then there's a roadmap for the future development. The final example here is from a student competition conducted at Chalmers, with also some support by White. A student-driven competition for climate neutral or climate positive, actually, prototype buildings, where additive manufacturing was explored by the students. The background here was initially that side streams or leftover material from the timber industry can be reused and made into biocomposite materials, which makes it a sustainable solution, complementing timber construction in general. The student competition is a recurring event, and this particular year it was aimed at making a prototype building in Wuppertal, Germany, where, for instance, rooftop extensions was one particular theme that the students took on. And the additive manufacturing principles were developed and managed together with Rice in Gothenburg, and based on, at that time, existing technology, but also further developing that, in particular in terms of the design methods. So students went quite explorative here and looked both at the production technology and the scope of the competition, and explored quite expressive solutions, so to speak. But ultimately, one smaller building prototype was defined and designed through teams. Many design studies, of course, using small-scale printing technologies, and finally also producing it at full scale, different parts. This was one of the first prototypes and demonstrators presented at Chalmers previously. And finally, construction planning and testing at Chalmers still, and ultimately building the building. And you can see that only a small part is actually produced by additive manufacturing. It was a combination. So here, key development work was done in trying to connect in a similar way as the Reese cases, the design model with the production principles, and the very basic ways of doing 3D printing that everyone can do these days goes from a model through an automated slicing principle to a 3D printer. But here we started to look at more advanced way of actually controlling the tool path in different ways, simulations, and then creating the G-code is used. So through several steps, this was made into more and more advanced solutions for more and better control. And ultimately, the prototypes were going through a number of steps where also the design itself was partly automated. So those were the cases that we worked on, and it's quite easy to see maybe a few challenges here. Each of these computational design workflows is bespoke, and it's also self-contained in many ways. A good thing is that the technical visual scripting platform and the design environment is actually the same between these very different scales. We still see the true potential for a more integrated data approach as being untapped. And one thing that was identified mid through the project is the need for a cloud-based platform of some kind for a data exchange, coming back to the thoughts of how this can be related to urban digital twins. And Speckle as a platform that we used and tested, which was still and is still under development. So to give a brief overview of what this challenge and potential is, these are 4 of roughly mapped workflows that are, of course, distinct and, as mentioned, bespoke for these particular cases. But what we have seen is that in all of these 4 cases, they could benefit from data made available, for instance, through a digital twin directly, and they could also contribute in different ways. This has been a very rough mapping of these potentials here. And in the actual cases, for instance, in the bridge case, we did use urban data, but we did not have in the commission the possibility to use a digital twin in that case, which would have been very beneficial. So the setup for this prototypical development has been around the modeling toolkit Rhino, which has its computational aspects developed in Grasshopper, and then have Speckle as this platform where the data exchange can happen. And it's still sort of at the proto stage, but there's a belief that Speckle could then also be used further on if that's being developed at the Digital City Center and allow these measures. One key aspect that was also pushed and still is, I believe, by Parametric, is a validator of the data, because with these very bespoke processes, there's no way to standardize the data being generated or actually being needed either. So a validator would check it so it conforms, basically. But there are different views of how data could be received from the DTCC platform. Obviously, the urban contextual data would be very valuable, but also look at how it could actually be exchanged during the design process and once there is a proposal, of course, to contribute to that. So to sum up, there is a report or an assembly of the findings being compiled still by myself. But the proposal from the project is that Speckle is an interesting data model to have sort of an agnostic middle layer for exchange. There's been work producing types and schemas for this data exchange. This validation is potentially optional, but can be included. And there's also been a parallel study of semantic web technologies and an overview over the different options we considered before Speckle, and that will be part of that. So that's my conclusion, and thank you if you're watching this as a video later or if you're part of it now.